Kindly don't make noise, okay? Okay, then the network performance, it can be judged via two parameters that the most important parameters to judge the performance of network. These are the latency and the throughput. What is latency and what is throughput? You have listened to the lecture and you have also read through the PDF. Any student who can tell me what is latency? Hello, students.
जी सर.
What is latency? Kindly बताएं what is latency? जी बिलाल आसिफ.
Yes, sir.
What is latency?
No idea.
What is latency? Okay, latency is the sum of all delays in the network, and its units are in seconds. So we will be discussing all types of delays, which are propagation delay, transmission delay, and processing delay. For that purpose, let's see a 6-node switching diagram. This is a 6-node switching diagram, an example of a wide area network in which A is connected to B via this particular wide area network. And these are the trunks, which are the communication links that are connecting these two switches or the nodes. And these trunks are the shared links. Shared means that many users' traffic can pass through these links, not only A or B, but if other users are also connected, they can also share these paths. Okay.
Okay, sir.
आप लोगों की आवाज कोई क्वेश्चन या कोई चीज नहीं आ रही. Kindly ask anything if you are not understanding this.
सर इसको दोबारा एक्सप्लेन कर.
Okay, this is a six node diagram representing a wide area network in which users A or B are connected, and these nodes are connected via each other with a communication links known as trunks. And these are basically communication media that is used to share traffic between different users. Now, when a user A sends certain data to user B, there are certain delay components that are involved when the data is being sent from A and then the data reaches B. There are certain delays that are experienced. Now, these delay components or end-to-end delay, what are these? Now, first of all, it's the transmission time of a message. The first delay is the transmission time of a message. We will be discussing how much delay this transmission of a message can create and what does this mean. A basic definition of transmission time of a message is the time elapsed from the moment the first bit is transmitted till the moment the last bit is transmitted. What do you understand by this definition?
इट मीन्स पहला जो फर्स्ट बिट जब स्टार्ट होना होती है ट्रांसफर, जब उसके और उसकी ट्रांसफरिंग के स्टार्टिंग से लेके उसकी रिसीविंग एंड तक पहुंचने तक जितना टाइम चलता है उसी ट्रांसमिशन में।
नो, देखिए, keep this in mind कि transmission time of a message has nothing to do with the receiver. Transmission time of a message है, देखिए, you have a transmitter and you have a receiver. Now the transmitter starts transmitting a message. Message consists of certain bits. Let's suppose that your message consists of 10 bits, 11100001111. Now, first of all, when first bit is transmitted, the time elapsed from the moment the first bit is transmitted. उसके बाद second bit transmit होगी, फिर third bit transmit होगी, and eventually the last bit will be transmitted. So this is the time how many minutes or how many seconds it takes for a complete bits to be transmitted only. It has nothing to do with the receiving of these bits. It is just the transfer or transmission of these bits from one end. Okay, this is the transmission of time of a message. It has nothing to do with the receiver. The receiver ने receive कर लिए bits or whatever. It is just at the transmitter end. A transmitter, how many time, how many seconds transmitter is taking to launch those bits on the communication link. You get the point?
यस सर।
ठीक है, इसमें रिसीवर का कोई पॉइंट नहीं है, इसमें है कि हाउ मच टाइम द ट्रांसमीटर इज टेकिंग टू लॉन्च दोज बिट्स ऑन टू द कम्युनिकेशन लिंक. Obviously, let's suppose there are 100 bits in a message. So transmitter will start with the first bit, second bit, third bit, and eventually all the bits will be launched on the communication link. Okay? Obviously,
यस सर।
transmitters are very fast and it is not asynchronous transmission, which is bit by bit transmission. Rather, the transmitter transmits many bits in a group. So it is very fast. Don't think a transmitter, if you have to transmit a 1 megabyte file, the transmitters will take so many seconds. Basically, transmitters are very fast and they transmit in groups. So the transmission time is the time elapsed from the moment the transmitter transmits first bit till the moment the transmitter transmits the last bit of the message. This is the transmission time and it has nothing to do with the receiver. And the formula for calculating the transmission time or transmission delay is the length of the message in bits divided by the bit rate or the data rate in bits per second. Remember, if you have bits in the numerator, you must have bits per second in the denominator. Or if you are having bytes in the numerator, you should have bytes in the denominator. So it is best if you are given bytes or kilobytes, you convert them into bits. And bit rate or data rate is mostly given in bits per second. But if it is given in bytes per second, multiply it by 8 and convert it into bits per second or into bits. Okay?
एक्सक्यूज मी सर।
Yes.
सर ये बिट ड्यूरेशन एंड टाइम ट्रांसमिशन मैसेज यानी ट्रांसमिशन टाइम ये दोनों सेम ही है, बिट ड्यूरेशन और ट्रांसमिशन टाइम?
No. देखिए, the bit duration in this signal, you see this square wave is representing 1010 certain bits. This one is represented by this part of the bit. This bit is represented by 1 and this is its bit duration. यानी कि जो one signal है, जो one binary value है, उसको इस signal element से represent किया जा रहा है and the duration of the signal element is this TB bit duration. कि duration क्या है? One जो signal element represent कर रहा है, उसको उसकी बिट ड्यूरेशन क्या है? देखिए, जीरो की बिट ड्यूरेशन, दिस इज द बिट ड्यूरेशन फॉर जीरो, and this is the bit duration for 1, this is the bit duration for 1. Okay, when the signal is launched on the medium, so bit duration tells ke how much, which level or how do you, or how much time, कितने टाइम तक का जो सिग्नल है वो रिप्रेजेंट कर रहा है पर्टिकुलर बिट को.
सर फिर फॉर्मूला तो सेम ही रहेगा ना फिर दोनों में?
तो बिट ड्यूरेशन का फॉर्मूला सेम रहेगा. For example, TB is the bit duration, then 1 over TB is the bit rate. Bit rate is the reciprocal of bit duration. Let me show you another diagram. Just a second. Okay, can you see this diagram?
Yes, sir.
Yes, sir.
In this diagram, you have two figures, A and B. The first figure is representing how many bits are traveling in 1 second. And then you can see in the diagram below that another 1 second and the bits have increased. In the first diagram, bits are transmitted at 1 megabits per second. 1 megabit means ke 1 over 10 raised to the power 6, you see ke every bit is 1 microsecond wide. It means ke the width of the bit is 1 microsecond, or the TB is 1 microsecond, the bit duration, this one. This thing, ये जो एक brick या एक slab है, it is the TB, the bit duration. And in the first part of the diagram, it is 1 microsecond. But when we increase the data rate to 2 megabits per second, you see that now we have 2 bits instead of 1 bit time. जब data rate 1 bits per second था, तो you saw only this one slab. But when we increase the data rate to 2 megabits per second, now we can have 2 bits, 1 and 0. Previously, we had only 1. Bit duration, in this bit duration, we had only 1 when the data rate was 1 megabits per second. But when we increase the data rate for 2 megabits per second, we can have 1 and 0, 2 bits in this particular bit duration. You get the point? Hello?
Yes, sir.
So this is bit duration, or the transmission time of a message hai, I told you that it is the length of the message in bits divided by the bit rate. You get the transmission delay or the transmission time of a message. Okay, how much time it will take for the transmitter to transmit those bits onto the communication link. It has nothing to do with the receiving of the bits. It is just the transmission of these bits. कि कितना time लग रहा है इन bits को transmit करने में. Okay? Any question?
सर ट्रांसमिशन ऑफ द मैसेज और ट्रांसमिशन डिले सेम है ये दोनों?
Yes. Transmission time of a message means के कितना delay experience हो रहा है. Transmission delay और transmission time of the message is the same thing. T-trans is the transmission delay or the transmission time of the message in seconds. Similarly, next delay is the propagation delay or the propagation time. Okay, how much time it takes for the bit to arrive at the receiver. Now we are talking about receiver. Previously, there was no point of receiver, just the transmission. But when we talk about propagation, it tells this is the time elapsed from the moment the first bit is transmitted till the moment that bit is received. Then you've got a communication link. Here is the communication network, wide area network consisting of 6 nodes. and a user wants to send a certain message from A to B. So what will be the propagation delay? Propagation delay tells okay, a bit, how long it takes a bit to travel from A over this network to B. This is the propagation delay. Any bit of a message to travel from A to B is the propagation delay. You get the point?
Yes, sir.
This is the time
Yes, sir.
from the moment the first bit is transmitted till the moment that bit is received. It is not necessary that we talk about only first bit. We can talk about any bit in a message. Okay, how long it takes from it, how long it takes for a bit to arrive at the receiver. Now, this propagation delay depends upon the physical length of the link. It doesn't depend upon propagation delay, doesn't depend on the data rate, doesn't depend upon the size of the message. It only depends upon the physical length of the link in meters divided by the speed of the light in meters per second. Physical length of the link क्या है? The physical length of the link. In this diagram, you see that there are certain links. There are 1, 2, 3, 4, 5, 6, 7, 8 links that are connecting these 6 nodes. Now the propagation delay depends upon the length of these links. If A wants to send certain data to B and we will have to calculate the propagation delay. So we have 3 communication links here, 1, 2, and 3. We will add the length of these links and divide it by the speed of the light. We will get the propagation delay. Okay, what is the propagation delay for sending a bit from A to B? Okay. Hello students.
Yes, sir.
Propagation delay की समझ आई है?
यस सर कि मतलब फर्स्ट बिट का ट्रांसमिटिंग स्टार्ट होना और लास्ट बिट की रिसीविंग हो जाना, उसमें जितना टाइम लगता है उतना।
No. That is transmission delay. इसमें ये
नहीं, लेकिन
है
सर उसमें
propagation.
रिसीविंग नहीं ना था।
No, propagation delay में you have to take any bit of the message and it is the time that that particular bit takes to reach the destination. All bits नहीं है. Any one bit, or if you, let's say, suppose you take the first bit, the time it takes from the moment the first bit is transmitted till the
यस सर,
वही फर्स्ट बिट जो है वो रिसीव कब हो रही है,
यस सर,
इसमें लास्ट बिट की कोई बात नहीं है. ओके, एनी
ओके सर,
बिट ऑफ द मैसेज कब ट्रांसमिट हो रही है और कब वो बिट रिसीव हो रही है इज द प्रोपगेशन डिले.
ओके सर,
ठीक है ना. ट्रांसमिशन डिले इज कि आपका फर्स्ट बिट ट्रांसमिट होती है, उसके बाद हाउ लॉन्ग इट टेक्स फॉर द ट्रांसमिटर टू ट्रांसमिट द लास्ट बिट ऑफ द मैसेज इज द ट्रांसमिशन डिले. Propagation delay, it is the time elapsed from the moment आपकी first bit transmit हुई or how long it takes that particular first bit to reach to the receiver. This is the propagation delay and it depends upon the physical length of the link. Okay. One important point in calculating
Excuse me, sir.
propagation delay is that if speed of light is not given and the speed of transmission of bit in medium is given, such as 2 into 10 raised to the power 8 or 2.5 into 10 raised to the power 8, then you will use these values. If nothing is given, then you will use the speed of light. But make sure that if you are using speed of light 3 into 10 raised to the power 8 meters per second, then the physical length of the link should also be in meters. It should not be in kilometers. The units should be consistent. Okay. Now let's see in this example.
सर
Yes.
सर अगर एक मैसेज में 10 बिट्स हैं तो सबका प्रोपगेशन डिले सेम होगा?
नो,
Propagation delay जो होगा, if there are 10 bits in a message, the propagation delay will be same. Propagation delay does not depend upon the length of the message. You see the formula of propagation delay. Propagation delay के अंदर, are you seeing any length of the message?
No.
No. In propagation delay, it is only physical length of the link. If a message is 1 megabyte, if a message is 10 megabyte, whatever the length of the message, the propagation delay will remain same. Propagation delay only depends upon the physical length of the link. It does not depend upon the length of the message.
Yes, sir.
But transmission delay, it depends upon transmission delay depends upon the length of the message. If the length of the message packet length is 100 kilobyte, the transmission delay will be different. If the packet length is 1 megabyte, the transmission delay will be different. Okay.
Yes, sir.
And then you see there is an example here. For example, consider the following satellite link, and we need to calculate the end-to-end propagation delay. This is a satellite, a geosynchronous satellite that is orbiting the Earth at a distance of about 36,000 kilometers. And these are the antennas, the sending antennas, the receiving antennas, the parabolic dish antennas. So we have to calculate the end-to-end delay, propagation delay. So how many communication links are in this diagram? Hello, how many communication links are in this diagram?
2, sir.
2. One from this sending end and the other for receiving end. So if we calculate the propagation delay of this link and we multiply it with 2, we get the total propagation end-to-end propagation delay. And this is the same formula for propagation. What is the propagation delay formula? Length of the link. In this case, the length of the link from sending end to for this satellite is 36,000 kilometers. 36,000 multiplied by 10 raised to the power 3, we will get meters. Divided by the speed of light, 3 into 10 raised to the power 6, we get 0.012 seconds. Or 0.012 seconds multiplied by 1000, we get 120 milliseconds. Okay. Now, this is for one end, and we multiplied with 2 to get the total end-to-end propagation delay, which is the 240 millisecond. Okay. These students,
जी sir.
you get the point? Propagation delay, transmission delay.
जी सर. अच्छा सर, ये प्रोपोगेशन डिले जो है ये मीडियम के ऊपर डिपेंड करता है? किस स्पेसिफिक मीडियम के ऊपर आप ट्रांसफर कर रहे हैं कोई भी चीज?
Very good question. It does depend upon medium. Here you see if the medium is air and the electromagnetic waves are going through vacuum, we use the speed of light 3 into 10 raised to the power 8 meters per second. But if the communication link is of copper or any other medium, you will be given the speed, the speed in the medium, the speed of the electron is what, 2 into 10 raised to the power 8 or 2.5, which is lesser than the speed of the light. Okay?
Yes sir.
Because the speed of light in vacuum is 3 into 10 raised to the power 8, but the speed of light in other mediums such as copper or other things, अगर हम इसको देखें तो the speed is reduced. So this does depend upon the medium, but you will be given what is the speed of electrons in that particular medium. Like a question जो आपका assignment है उसमें भी you have been given the speed of transmission in the medium. आपको दी हुई है ना उसमें?
जी सर, असाइनमेंट्स आई हुई हैं.
let me open assignment. Okay, here the data travels over the link at the speed of light, which is 3 into 10 raised to the power 8. 8 was missing. Let me correct it. इसमें 8 ऐड कर लें. The speed of light is 3 into 10 raised to the power 8 meters per second. Okay.
Yes, sir.
Speed of the light is 3 into 10 raised to the power 8 meters per second. And in assignment number 3, let me check. Here you see question number 3. The speed is given as 2.2 into 10 raised to the power 8 meters per second. Okay, because we are taking a transmission speed in a local area network, which is must be connected via category 3, 4, 5 cable. And here the speed is not the speed of light, but it is a bit lesser. It is 2.2 into 10 raised to the power 8 meters per second. So it does depend upon the medium. Okay. I hope this clears your question. Hello.
जी सर बिल्कुल ठीक है.
Okay, now two things are clear: transmission time of a message and the propagation delay. Now the third type of delay is the keying delay at each node. And then the fourth one is the processing delay at each node. So what are these delays? Keying delay and processing delay. Let me go to the diagram above. Okay, if this session terminates, I'll be initiating another session in a moment. So join that particular session if this session gets off. Okay. Now you see this is a diagram in which we have these nodes, switching nodes, and a person at A wants to send a message to B via this wide area networks using these routers. So when a particular message will be coming to these switching nodes or these routers, the particular message will be held up in the buffers of the routers. A router has incoming and outgoing buffers. Every node has incoming buffers and outgoing buffers. And the packets that are coming are held in these buffers in line in a K before they are processed by these nodes. So the time the packet spends in these buffers, in those lines, those Ks is the keying time or the keying delay. And when those packets come to the router to be processed and router's processor process these packets, the time that will be used to process these packets will be the processing delay. So these are the two delays, the keying delay and processing delay at every node. And these delays you will be given, the value of these delays will be given. You won't have to use any formula to calculate these delays. But these delays, every delay is at for every particular node. If there are 4 nodes, the delay will be multiplied by 4. If there are 4 nodes, the processing delay will also be multiplied by 4. Okay, any question related to keying delay and processing delay?
ये keying delay में random component और ये EE465 kindly इसे जरा explain कर दीजिए.
इसको don't worry about this. Basic, this is the course code for probability and high speed advanced networks. So it don't bother about EE465, double triple five. It is just that the teacher was saying at this point that you need to know probability and advanced networks in order to study these subjects in detail. So don't worry about these things. Just worry about the basic definition about keying delay and processing delay. कि keying delay और processing delay होता क्या है, जैसे मैंने आपको बताया. Okay.
Okay, sir.
Keying delay is a random component, means कि keying delay varies at every node. At every node, the keying and processing delays are different depending upon the congestion on these nodes and the speed of the packets that are coming in the node and are being sent outside the node or on the outer interface. But normally in examples or in practical, we take all these keying delays and processing delays per node as constant. So don't worry, we'll be taking keying delay and processing delay for every node as constant until and unless you are given kg which router has how much keying delay and what is its processing delay. Okay.
Yes.
सर ये इसको 4 से क्यों मल्टीप्लाई करेंगे?
No, it depends upon how many routers or how many nodes are involved. In this case, okay, let's suppose a message from A to B goes from this upper path 1, 2, 3, 4. It takes 4 routers. Then we'll be multiplying with it 4. If there are 5 or 6 routers, then we'll be multiplying the keying delay with 5.